Okay, hi again. That's my cat. This is another. Well, I wanted to re record this because last time it wouldn't turn on. So I put it in the light for a day, and now this button here. Wow, it turns on and it's super bright. And this will last for a day or something. Here, kitty, look in the light. Look in the light. Don't look at the light. This is a solar powered USB thing, and it does not put out enough to charge your phone. It does put out enough for very low power USB devices like LED light things. Let me turn this off now so it's easier to see. Like LED light sticks, or I don't know, tiny little fans. Anyway, so there are 3 on this side, and then 3 solar panels on this side. These are all wired together in parallel. They're 2.5 volts. These are all wired together in parallel, 2.5 volts. Each one of these, I think, is 100 milliamps, maybe 50. That's I don't really remember. But the point is 2.5 volts. So at some rate, these all charge up in parallel, 2.5 volts. I don't think I had any Schottky diodes off of the solar panels, which was not good at the time. So that's bad. You need Schottky diodes coming out of the positive of these to prevent the capacitors from leaking back into them when there is no sunlight, because that will keep the solar panels working longer. So I should have done that, and that would have worked fine too, but it's okay. Anyway, so right now the solar panels just go into, these are two 15 farad 5.5 volt capacitors. So it says 5.5 volt. I'll talk about that later. So that's 30 farads in parallel there, and then these are also in parallel. There's 2 on this side, and those are 10 farads each. So that's a total of 50 farads at 5.5 volts, right? And then that goes through this switch over here, which then goes into the voltage booster in the back there, which is a 0.9 volts to 5 volts at, I think, 200 milliamps, it says. Not sure if it gets to that. Yeah, so anyway, so the point is it only charges these up to 2.5 volts. Actually, in the sun, I think they get up to, I think this, well, I skipped there. I think the solar panels actually get up to 2.8 volts in full sun or something like that. So you have to be careful because they can't go over. But you don't want that voltage going over the maximum voltage of the capacitor rating because they could get damaged or blow up. So instead you want to have, if you're doing just in parallel like this, you want the solar panels to be less than the voltage of these. Okay, and in terms of the casing here, these are 2 like screw boxes, tool screw boxes that I use. They're nice because then I can seal this up and then clip these things and then work on it again. Yay. So also on the side I put Velcro so I could Velcro it to something. It also makes it look prettier. So now let me talk about these capacitors for a second. So you would think, okay, 5.5 volt capacitors, I can put something up to that limit on here, or at least under that limit. Excuse me. But I disagree. So normally the chemical nature of the capacitors, you have 2 plates and you have an electrolyte between the 2 plates. It's normally like aluminum sheet or sometimes graphite coated aluminum, or more lately graphene coated aluminum sheets for supercapacitors. I don't think these have graphene in them. It's probably just high quality graphite or something. But Anyway, you can only, in one cell of a capacitor, chemically, you can only get up to like 2.7 volts. So what they did here is they combined both of these in series to get up to 5.5 volts. That's bad though, because one of these, there's actually two cylinders in here. One of these can get higher or lower than the other. They will discharge at a different rate. One of them might go negative, or one might become more positive than the other. Anyway, it'll end up screwing them up over time, and the lifetime of these will last significantly less. One cell by itself would normally have a lifetime of like 300 years. If you put them in series and you do not have any load balancing circuits to ensure that they do not go negative, to ensure that they do not become more positive than their voltage rating, then they will degrade and you'll end up with a lifetime of like 10 years. So this is probably fine for 10 years, but the point of this concept is to create an emergency charging device or flashlight that can be left on the shelf, left in the window, and not have to be checked every year to ensure it's still working. Because if you use lithium batteries or nickel cadmium or something like that, then, or nickel metal hydride or whatever, those batteries go bad in like 2 years or 5 years. And I know all of you out there have had to replace your laptop battery before or your phone battery. But so instead, these are capacitors. So this one at least would last like 10 years. But some of the other videos that I've posted or will post have examples of how to boost that voltage up. Like I said, the voltage booster goes from 0.9 to 5 volts. So as long as you can get 0.9 volts stored on those capacitors and then have enough capacitance and be able to boost that up to the voltage at the current you need, then you could have a device that actually lasts for 300 years and not have to worry about constantly checking that your emergency system, which is made to not have to have a lot of maintenance, is still functioning. So anyway, this is better as a small form factor, but yeah, some other videos that have better ways of doing this. So we'll go watch those. But this one's cute though. It kind of fits in your pocket and feels nice in your hand. All right, goodbye.